All right, let's turn to page 367 to look at our Explore It. It says Sarah wants to score 78% on her next test. She knows the test will have 40 questions. How can Sarah represent the situation to determine how many questions she needs to answer correctly? So let's say that these ones that I'm going to scratch out, right, which you can do in the book if you have this provided for you. So we have 1, 2, 3, 4, 5, 6, 7, 8. And then we have 16. And then we have 24. And then we have 32. So we have 32 out of the 40 that she got correct. All right, so let's take a minute to do that. Now, it could be any. I just picked these ones random because it just makes it easier on me. And then for part B, it says, how could you use the model to help solve the problem? So what we can do now is that we know that 78% is roughly a good approximation close to 80%, which means it could be 8 out of 10 based off of what we've seen before. So 8 over 10 is 8 out of 10. And we know that there's more than 10 questions on there, right? So you could say I shaded, or we shaded, 8 out of 10 for each row, 8 out of 10 for each row. That's what we did, because we ended up getting 32, which is 32 questions. All right, so we kind of broke it down to something smaller, and then we looked at the whole thing. And this is exactly what Sarah wants to get in terms of her test. So closer to 80% makes it a little bit easier on us, okay? So make sure this is written in on page 368. Follow along with example 1.
How can you use fractions to estimate percents? Think about this question during the lesson. This graph shows the eye colors among 500 students at a school. About how many students have brown eyes? Blue eyes?
You can use what you know about percents and their fraction equivalents to estimate.
So if you take a look at brown, all right, so brown was at 46%, right? We can call that half, right? Estimate that as half. So we could say that 250 kids have brown eyes. And then for blue, it was 23%, which is roughly a quarter of that. So you could say that that's about 25%, meaning that that's half of a half. So we could say 125 students roughly have blue eyes.
According to the graph, 46% of the students have brown eyes. Estimate 46% of 500. So 46% of 500 is about 1/2 of 500. About 250 students have brown eyes. Why do you use 50% here? Why are the numbers compatible?
Well, 50% is something that, as we've seen in this chapter, that is a little bit more of a benchmark percent slash fraction slash decimal. So it's much easier to use than 46%.
50% is easy to use because it is equivalent to 1/2. You can compute 1/2 of 500 mentally. Why not use 45%? Explain.
45%, as we said before, is not really a benchmark fraction or decimal.
45% is equivalent to 45/100ths, or 9/20ths. You can use 45%, but those fractions are more difficult to compute with mentally. According to the graph, 23% of the students have blue eyes. Estimate 23% of 500.
So that's going to be 125, as we said.
You can use 25% to help you estimate 23%. Which is an equivalent fraction for 25%.
Well, that should be 1/4.
25% equals 1/4. So 23% of 500 is about 1/4 of 500. About 125 students have blue eyes. Now you know how you can use fractions to estimate.
All right, so let's look at the triad here. It says, suppose the graph shows eye colors among 120 students in 6th grade. About how many 6th grade students would have green eyes? Explain how you can estimate Use estimation to find your answer. So green is right here, that's 16%. 16 is roughly 20%, okay? 20% is the same thing as 1/5. So we could do 1/5 times 120. All right, we can cross cancel. We get 24, so about 24 kids have green eyes. So that's what we want to write in there for 6. All right, let's take a look at example 2. It says use the results of the survey shown at the right about how many high school students plan to get a summer job. So 50% of 94 students surveyed plan to get a summer job. Now that 53%, it's much easier to use 50%, all right? Or we could round the number of students to 94, right? So half of 90, so we could actually do half of each. We could make that 50%, we can make that 90. So a good estimation would be 45, or we could simply just say half, or 100. 100 is still relatively close to 94, and half of 100 is 50. So that's another way we could do that. Right now, for the try it, it says use rounding to find 44% of 56. All right, so 44% is close to 40. So we'll do 4 over 10, or 2/5, right? 56 rounds to, so let's take a look here. And then we do 2/5. This rounds to 60. This number here rounds to 60, so we do 2/5 of 60, which ends up getting us 24. So we could say about 24 students plan to attend summer camp. All right, another way we could do this is we could do 4 over 10 again, 2/5. All right, we could go with 50 instead of 60. We'll take that same approach, 2/5 of 50, ends up getting us 20. But take note that these two numbers are not completely far off from one another, so that's a good estimation. Remember, estimations aren't exact, okay? So write that in for page 3.